I was asked to do more practice problems with u-Substitution, and these two are from Pre-Calc Benchmark Pretest 3. Um, and these are questions where specifically we have two variables that we want to write in terms of each other, and they're written uh, both in terms of a third variable with exponentials. The first thing that I want to notice is the part in common between these two problems is u equals 3 to the x. 9 to the x can be rewritten as u equals 3 to the x squared, because this is the same thing as 3 to the 2x, which is 9 to the x. So u squared equals 9 to the x, and we can substitute that in over here. U squared plus 5, and this is 3 minus u. What is a in terms of b? So we want to get b in here and get rid of u. So let's solve this. So the idea is, if we solve this equation for u and substitute it in over here, we could use elimination if this were not quadratic. The way we solve quadratic systems is by solving for one of the variables and then using substitution. So I'm going to add u to both sides. U plus b equals 3, and then u equals 3 minus b. Now we can substitute 3 minus b in where u is, and then we get a equals 3 minus b squared plus 5. Now that u happened to be 3 to the x, but you don't need that for the rest of the problem. Now we distribute. Hopefully you remember that 3 minus b squared is 3 minus b times 3 minus b. So you're getting 4 terms and then writing out the perfect square trinomial. And then we can combine like terms. B squared minus 6b, 5 plus 9 is 14. So that is a in terms of b. Let's do another one with the same idea. So this is number 7 from the same pretest. If you say u equals 4 to the x, you can rewrite both of these with u in them. Specifically, f of x, by your exponent rules, this is the same thing as 2 to the 2x times 2 to the first, or 4 to the x times 2 minus 1. So that's 4 to the x was our u, so it's 2u, 2 times u minus 1. So this is what f of x is. At the same time, g of x is 4 to the x, so u plus 1. Wait for that to be in black. So now what we've identified is that both of these have 4 to the x in them. So now that we've written them both in terms of u, now it's easy to solve one of them for the other. What I'm going to do is I'm going to solve this one for u and then substitute it over here. I'm going to solve this one for u by adding 1. Then divide by 2. And now we can substitute it into the other equation. G of x equals, u is f of x plus 1 over 2, plus 2. I'm sorry, this is plus 1. And now we can combine like terms, get a common denominator. And that common denominator is 2. Now we add the numerators. So f of x plus 3 over 2 equals g of x. So again, the strategy that we just did, and I'll write this down in a moment, was we figured out what was in common between the two equations, performed a u-substitution, solved one of the equations for u, and then substituted into the goal equation. So let's write that down. The steps that we took were first identify a u and substitute. Then once we had identified u, solve one of the equations for u, substitute into the goal equation. So just to recap, in the first one we identified 3 to the x, substituted in to get this blue and red equations, then solved the red one for u, and then substituted that u back in to the blue equation. Here, we identified u equals 4 to the x and substituted to get these two black equations, solved this one for u, and then substituted that into the g of x equation. Hope that helps.